Welcome to 9.4, the last module, last section of the ninth module. And we're going to do systems of linear inequalities, and that should be TWO, not TO, two variables. So really, what we're going to be doing is we're going to be graphing lines and then shading regions. So if we have two linear inequalities like this one right here, first thing we're going to do is graph the line y equals 2x minus 3. Then we're going to pick a test point to shade. Now, this has been shaded to this direction. Then we have another line right there. We graph that, pick a test point, shade this way. So the solution region is going to be this region down here that is the intersection of the regions, of the solution regions of these two lines. And same thing's true over here. Like, if we graph this right here, we're going to get this line. Okay, if we graph this right here, we're going to get this line. Then we want to shade. Now, when we graph this line, we pick a test point which tells us we're going to shade this way. When we graph this line, we pick a test point we're going to shade this way. Our solution region is this right here, where both those things are true. So we're really kind of using an and. Now, vertices of the solution set are the intersection points of the line. So this right here, that's a vertice. This right here, that would be a vertice of the solution. Okay? The other thing to keep in mind, if we have less than or equal or greater than or equal to, like we have here, we have solid lines. Over here, when we have less than, we have dotted lines. So that's kind of what's going on. So we'll just kind of jump in and do a problem. So first thing we have to do is look at this. Now, if we have 2x plus 3y is less than 6, first thing, because we have less than, we're going to want to use a dashed line here. Okay, so we're going to use a dashed line. Second thing we want to do is graph 2x plus 3y equals 6. So we could solve this for y, get it in that slope-intercept form, and then graph it from there, or we can plot points. I'm going to find the intercepts, because it's not already solved for y, which is kind of my condition. If something's already solved for y, I'll go ahead and graph it using the slope-intercept. If not, I'll use intercept. So here, I'm going to erase some of this. Oops. Erase some of that. I don't need all of that. So I'm going to do 0 there, then I'm going to do 0 here. So plugging 0 in for x, we have 2 times 0 plus 3y equals 6. This cancels, so we get 3y equals 6 divided by 3. Y equals 2. So that tells us when x equals 0, y equals 2, so 0, 2. That is our y-intercept right there. Now plug 0 in for y. We do that, we have 2x plus 3 times 0 equals 6. This cancels, so we get 2x equals 6 divided by 2. X equals 3. So when y equals 0, x equals 3. This is giving us our x-intercept over 2 points. Recall, because we have less than, we want to do a dotted line that goes through there. Now, when I was talking about the test point, we want to pick any point that's not on the line. I'm going to pick this point 0, 0. Now, we plug this back into our equation, this original equation right here. 2 times 0 plus 3 times 0. Is that less than 6? Well, 0 plus 0 is 0. 0 is less than 6. So this is part, because this is a true statement, 0, 0 is part of our solution set, so we're going to shade down, and we want to include that as our solution region. Okay? So if we just had the one line, this whole area underneath this line would be our solution region. All of that right there. So now we need to graph the second one. X is less than 5. Once again, we're going to use a dashed line. So we want to graph x equals 5. Now recall, x equals 5 is a vertical line that goes through 5. So it has this x-intercept 5. So we have that line right there. Now, so that's our line. And it's supposed to be a vertical line that's dashed. Just imagine that being dashed. I'm not really good at drawing, I guess, a dashed vertical line on this. So x is less than 5. We pick a test point again. We can pick that 0, 0, plug it in here. Is 0 less than 5? It is. So we want this to be part of our solution region, so we're going to shade to the left. Now, on my math lab, it just wants you to shade the solution region, which is to say, we're looking for where these things are overlapping. So if we think about our solution region, it's actually just this piece right there and this area underneath it. So in my math lab, you'll graph both lines, and then there's a little paint can icon. You'll click on the paint can and just select that region right there. So we found the solution region. Next thing we need to do is find the vertice. That is, we want to find this point where these two lines intersect. So, thinking about that, we're really solving the system. 2x plus 3y equals 6, and x equals 5. So we know our solution is going to be 5 comma something. To find our y, use substitution, plug it in there. So we can say 2 times 5 plus 3y equals 6. So solving that, 2 times 5 is 10, so we have 10 plus 3y equals 6. Subtract 10 from both sides. So we get cancellation here. So we get 3y equals negative 4. Divide by 3. And y equals negative 4/3. So x equals 5. Y equals negative 4/3. That is the vertex of our solution set right here, or the vertice of our solution set, and this is our solution region right there. So we'll pick it up in the back and do a couple more, but really this is about graphing lines, picking test points, and shading.